Hello, this is Mr. Tipton, and today we are looking at variable expressions for sequences. We've already talked about arithmetic and geometric sequences. Now we're going to solve or evaluate and write expressions for those sequences. Okay, a lot of times n, the variable n, is used for the variable that represents a term's place in a sequence. Alright, what we have in this table is, here if I can table it up for us, the first number in the sequence is 5. Okay, the sequence is on the bottom here. This is the actual sequence of numbers, S-E-Q-U-E-N-C-E, 5, 10, 15, 20. N is just saying, hey, 5 is the first number. 10 is the second number, 15 is the third number, 20 is the fourth number. Doing it this way, we can figure out, if somebody asks, well, what's the 17th number? Well, we can come up with an expression where we don't actually have to count by 5s 17 times. There'll be an expression for the sequence. For our first example here, we already have an expression, and we're just being asked, or being told, I guess, to find the first 4 terms, starting with n is equal to 1. Alright, so what does that look like? 2 to the first power is 2. 2 to the second power, we're looking for the first 4 terms, is 4. 2 to the third power is 8, and 2 to the fourth power is 16. Okay, find the first 4 terms. So we're looking at, we're evaluating this when n was equal to 1 and 2 and 3 and 4. These are the first 4 terms. Not too bad. Let's do another. Find the first 4 terms. Start with n is equal to 1. We're looking for the first term in the sequence. Let's see, if I sub that in, I'd have negative 7 to the, or not to the, negative 7 times 1 plus 2. That would be negative 7 plus 2 is negative 5. And when n is 2, I'd have negative 14 plus 2 is negative 12. When n is 3, oops, let's try that again. Negative 7 times 3 plus 2. Negative 21 plus 2 is negative 19. And one more, if I can squeeze it in here, negative 7 times 4 plus 2 is negative 28, plus 2 is negative 26. Alright, so again, these are the first 4 terms that go with the expression negative 7 times n plus 2. That's easy enough. Now, let's write the expression to describe the sequence. Okay, 8, 16, 24, 32. The way I think is easiest to do this is just to make a table like we had on the first screen. One more here. N and X. 1, 2, 3, 4. Remember, N is just the place. It's, 8 is the first number, 32 is the fourth number. Okay? The way I like to think about this is, what do you do to X? I'm sorry, what do you do to N to get X? And it has to work every time. In a previous video we talked about, well, this is plus 8, plus 8, plus 8, plus 8 as we move along this way, and that's true. That's what makes this an arithmetic sequence. But now we're trying to find out what is the sequence, what is the expression that represents it. And so we need to look this way. What do you do to n to get x? And maybe I should write that down somewhere, huh? What do you do to n to get x? Every time. Every time. Anyway, what do you do to 1 to get x? Or what do you do to 1 to get 8? You multiply by 8. From there to there, it's times 8. From 2 to 6, times 8. 3 times 8, 24. 4 times 8, 32. So every time the n is being multiplied by 8 to get x, which means our expression is 8n. If we wanted to figure out the 21st term, then we would just do 8 times 21, and we'd figure out that was 168. Okay. Another one of these, write another expression to describe the sequence. Again, I'm going to make a table. That was not a straight line. Let's try again. Better. Okay, first number, second number, third number, fourth number. And I know it's another arithmetic sequence because as we move this way, it's plus 1, plus 1, plus 1. But that's not what we're doing. We're not identifying the sequence. We are writing the expression that describes it. Okay, so what do you do to 1 to get 101? Well, you could multiply it by 101. But would that work over here? Is 2 times 101 102? No, that would be 202. That's not what we're looking for. What do you do to 1? What else can you do to 1 to get 101? You can add 100. 2 plus 100 is 102. 3 plus 100 is 103. 4 plus 100 is 104. So our n is having 100 added to it each time. That's the expression that describes the sequence. Strongly recommend making yourself a little table like this. If you have questions, keep track of them, and we'll talk about it in class. See you soon.